We are in mode of discussing similar design pattern. Okay, the design pattern which looks similar, but they are way different. We can consider it as orthogonal design pattern, but it looks similar. Okay, so in that terms, we have command design pattern and we have memento design pattern. So both are behavioral design pattern and they look same. So geniusity about the design pattern of the command and memento, they look same. Command also contains internal state, and when we call execute on it, then it does some action. Means it keeps something inside it. So if I have a 20 command, I can command objects. Then I can place the 20 command objects in a list, and one by one I can execute. Means I can call execute method, and it will start executing it. Okay, so whatever is it inside its internal state based upon, so it remembers something. So command keeps something state inside it, it remembers something. When someone say blast or I mean execute, then it starts executing. Memento, the name is memento. It remembers something. Okay. Now, but what are the differences? Okay. So when we say orthogonal, then inheritance and containment generally we consider as orthogonal. So first we see where command is generally used. Like I have a robot, and robot has four functions: move forward, move backward, move left, and move right. It has data structure. I don't bother. But robot, if I say move forward, it move forward, backward, left, and right. Now, but problem is that I cannot serialize the command in a list. I cannot have robots in a list. Okay. What I want is that I should have robot instances in a list, like in a list of 10,000. And I just start saying execute, execute, execute. Now come on, now robot, as per the execution, it will start moving. So if I say execute, execute, execute to 1,000 robot instances, then automatically it will start moving ahead, left and right. It is highly useful. So once I start process the list, then it should do certain action. Okay, it can go front, bend, dig something, or bring something, come back. So just I need to execute the list and all that. So this is highly desirable design pattern where I just need to call one function and all the robot instance would behave differently. But it has four functions and I need to call all those functions to make it behave differently. So that I don't want. So what I can do is I can have an interface called command class, and in the command class now there are two ways. So one way is that command will have a kind of a function pointer. So it will have just one attribute as function pointer, and another attribute obviously is the robot. So robot pointer and function pointer. Now each instance of, if I say command is not an interface, it's a class, then each instance of class has robot pointer and it has the function pointer. Now in the function pointer, it will point to either move forward, move backward, left, right, whatever function robot provides. So robot instance and any one of the function, it would just keep inside the command. So where this is where command remembers. Now all the command I can keep in a list, and I can say just execute. If I do execute, so based upon the robot, whatever the operation it remembers, it executes that. So four kind of commands I can think of here, four functions it kind of encapsulates. Now command I can put in a list, I can just say execute it. Whatever the operation it remembers, it will do. So this way we can keep the command in a list, or will have a command interface which keeps the robot pointer and all the derive will have one operation. So command left, command right, command forward, command backward, and each will have one operation pointer that is embedded. No need to kind of pass from outside when you instantiate. Now, since it comes through the command polymorphic way, command pointer, I can make a list of all command pointers. And when I say execute, and the instances would be command left, right, backward, and ahead. So whatever the derivation we are making, all derive object. If you have get any doubt, you can visit the about section of the YouTube channel. You get our website. There you can go for a design pattern training, and there we have two disclosures also. There you can go to command design. There we have played all possible ways where command can be done. So this way, through inheritance way, we have different commands left, right, uh, backward, and front. So all will get executed. Then instances are in list, and they execute the operation that is embedded inside. So finally, the aim is the command. Either we have command the concrete object or class or command interface through that we have four different classes concrete object, and through command pointer interface pointer we can keep in a list and keep executing it. Each keeps the one operation of a robot class, so they will execute, and finally a list would execute and it would happen. So we remember the operation inside it. So this is command design. Now we'll talk about memento. Like I have an adder. Okay. So a memento is like we also call originator. So adder is a class and it has two member variable, first and second. Now I fill first, I fill second, and call execute. It will add and return the value. So this is the function of adder. Now I am the perpetrator. I am the caretaker. I have 20 times I am doing add. Suddenly I remember that the third time I did something in addition. So that data is required. Means this is what. So if something I need to remember, then memento comes into the picture. Now I say the adder that okay, you added 20 times, 20 number I fed inside you and you gave the result through execute. The second time what I added, can you give me result again? Okay, that is the second time whatever the two parameter operands I provided for the addition. So that can you add again? So it would say what was it? That this also doesn't remember what was it. So then there is a there is a second class. So apart from adder, one class comes into the picture that is memento. So memento is if this is adder class originator and it has a member variable, exact replica of the adder will have memento. So each time, so if it has two argument first and second operand of the adder, then it will also have first and second. Now, when it executes, then the caretaker who is using the adder, okay, if it wants, then it can say that please remember it. If it says please remember it, then adder instantiate uh, one memento, copying its state whatever it is in, and return to the client caretaker. Because this is your memento. Okay. Now client keeps the list of memento and then whenever it wants adder to do something that has been done in past, it places that memento, adder absorb that memento, comes to that state because memento has those attributes only, and then it will do the addition. Okay, so this is the functionality. Now as per the design, what we see. Okay, so adder, that is the originator, it creates memento each time client asks to remember, and it returns it to the client. And client, okay, but client cannot do anything. It's a kind of opaque object to the client. Client does not know how to operate the memento. Everything is private, and there is no operation. So it's just a copy of the state originators or adders internal variable. There is no operation, and it's a private. It's an opaque product. It can't use it. It can keep it. It can remember it. It can keep in a list the way command design pattern with objects we kept in a list. So it can just send a list to the adder. This is the list of mementos, and can you just keep adding it and show me the result? So in a chain fashion, all computation can happen. So that is possible. The way chain fashion, the robot is executed. So things are similar, but things are orthogonal. First of all, the originator or adder keeps the command as containment. Okay, here the command keeps the memento as containment. Means memento, since memento everything has private, it is a friend of the uh, kind of the originator. So adder is a friend of memento. Inside memento class, we declare adder is a friend. So there is a statement friend adder. Now since adder is a friend, it can access its private variable. So whenever the client passes a memento to the adder, it accesses the variable, copies to itself. So it comes to that state and does the addition well. So each memento carries a state. But the biggest difference is that command design pattern, it keeps operation as internalized. It has operations. When you say execute, it executes the operation. Here, attributes are internalized. Okay, there operations are internalized. Here, attributes are internal. When attribute is an internal state, then it leads towards containment. Their operation is an internal state, it leads toward inheritance. So that is the biggest difference. So inheritance and containments are orthogonal. So though command design pattern and memento design pattern, they look similar, they keep the internal state, they can be kept in a list and can be executed serially, okay, through execute command or something like that. But one follows inheritance and other follow containment. So the originator class, the adder, keeps the all the memento something like containment, whereas the command design pattern, the all the commands, they inherit from the inheritance, from the interface, and then it follows the interface functionality. They have execute method, and finally the the function pointers, the function pointer that is also declared in the interface only, they assign as an operation. So one place the remembrance is operation, so it salutes inheritance. And in memento, the remembrance, what it remembers, is attributes non-operational, so it salutes containment. So originator kind of contains the memento, and memento contains attributes kind of that. Whereas their command interface, there we salute the inheritance, and command interface is is realized through all the commands like move left, right, and something like that. And then it executes the operations when execute is getting called. So this is something like so if someone understands the intricacies of inheritance and containment, then I believe the only thing that is need to be cracked well is a polymorphy, because in inheritance also we have a virtual inheritance, and there it is polymorphic. There V table comes into the picture, but still is fundamental also of the inheritance and containment helps. So I mean careful and be and enjoying life with the similar design pattern and how orthogonal things, they give more pleasure.